Hi student, I'm back again with a new topic. What we are going to do today is equilibrium, a very important topic. More likely to be asked question from this topic. So we are going to cater to some very important questions from this topic. So let's begin with it. Okay student, let's begin with the question session and the answers. The first question is, for the reaction SO2 gas plus half O2 gas having equilibrium with SO3 gas, if Kp is equal to Kc into RT raised to x, where the symbols have usual meaning, then the value of x is it going to be -1, -half, +half or 1? So let's see the solution for this question. Now we all know Kp is always equal to Kc into RT raised to delta n. Now what is delta n stands for? It stands for moles of gaseous product. Moles of gaseous product minus moles of gaseous reactant. Now look at this equation. The moles of gaseous product. So this is gaseous product. The mole is 1 here. So we take 1 minus gaseous reactant. Now both the reactants are gas. So 1 plus half. So this will be 1 plus half. So delta n answer is -half. Delta n is -half. What is given to you? Kp is equal to Kc into RT raised to x. Therefore, x is nothing else but delta n. And what is delta n value? -half. So your answer for x is -half. That is, answer is B. Answer is B for your question. Okay student, let's see question number 2. A very interesting question. Consider the following gaseous equilibria with equilibrium constant K1 and K2 respectively for these two equations. SO2 gas plus half O2 gas giving us SO3 gas having an equilibrium. This is equation number 1. 2SO3 having equilibrium with 2SO2 plus O2 gas, equation number 2. How are the equilibrium constant related with? Now it's a very interesting question. Let's see the solution part of it. Let us consider equation number 1. Let us take this equation number 1, for which I can write K1 is equal to concentration of SO3 upon concentration of SO2 into concentration of O2 raised to half. This is your equation number 1. Now for equation number 2, you can write K2 is equal to concentration of SO2 raised to 2 into concentration of O2 upon SO3 raised to 2. This is equation number 2. Now do one thing. In order to get the right hand side similar here, what we do is we square equation 1. Squaring equation 1. Squaring equation 1 squaring equation 1, we get K1 square will be equal to SO3 square upon SO2 square into O2. This becomes your equation number 3. Now, in order to get the relation between K1 and K2, multiplying equation 2 and 3, multiplying equation 2 and 3, what we get? K1 square into K2 will give us answer 1. So therefore, K1 square will be 1 upon K2. This is the relation between K1 and K2. So your option for this will be K1 square should be equal to 1 upon K2. So your answer is B for this question number 2. Okay students, let's see one more interesting question. If the value of Kc for an equilibrium reaction is 10 raised to minus 4, then the reaction is in which direction? Now, we all know if Kc value is greater than 10 raised to 3, then the reaction goes in forward direction. But if the Kc value is less than 10 raised to minus 3, then the reaction proceeds. Reaction goes in backward direction. Now, look at the value of Kc given to you. Given Kc is 10 raised to minus 4. That means it is less than 10 raised to minus 3. So reaction will go in the backward direction. So your answer for this question will be A. A is the correct answer for this question. Now we go for the next question. The gaseous reaction A plus B gives you 2C plus D plus heat is given out, is most favored at. Now this Q stands for heat which is given out during the course of the reaction and equilibrium is obtained. Now just analyze this equation very carefully. What is your observation? Heat is liberated. That means we understand it is exothermic reaction. This is an exothermic reaction. This is the first observation which you make it out from the equation. Second observation, can you see it? During the course of the reaction, the volume is also increasing. Volume is increasing. So, it's an exothermic reaction and volume is also increasing. So, according to Lee-Chatelier's principle, this reaction, if it is exothermic and the volume is also increasing, so low temperature and low pressure will favor the forward reaction. So low temperature and low pressure will favor the reaction. Okay, so your answer for this question will be D. which is low temperature and low pressure. Okay student, let's see one more very interesting question. Which of the following is not a Lewis base? Now first of all, what is Lewis base? According to Lewis, a compound, a substance which is capable of donating a pair of electron, is a Lewis base. The one who donates a pair of electron to form a coordinate bond is called Lewis base. And Lewis acid, which accepts a pair of electron to form coordinate bond. So let us take one by one. First option, if I take ammonia, nitrogen has 5 electron in its outermost shell. 1 electron it is sharing with hydrogen. It has 1 lone pair which it is capable of donating. So according to Lewis, ammonia is a Lewis base. It's a Lewis base. What about the second option? B, water, HOH. Oxygen has 2 lone pairs. So again it is a Lewis base. It has 2 lone pairs. What about aluminium chloride? Aluminium has 3 electrons in its outermost shell. 1 electron it is sharing with chlorine. 1 electron it is sharing with chlorine. But total electrons in the outermost shell of aluminium become 6. That means it is having a shortage of 2 electrons for octet. So it will be accepting a pair of electron. Now since it is accepting a pair of electron, it is a Lewis acid. So they are asking you, which of the following is not a Lewis base? So definitely the answer should be aluminium chloride. It has incomplete octet. So your answer is C for question number 5. Let's see one very important question now. It says, how many liters of water must be added to 1 liter of an aqueous solution of HCl with a pH of 1 to create an aqueous solution of pH 2? Oh, very interesting. So what are they asking for? They are telling you, look, there is a solution, there is 1 liter solution. So the initial volume is 1 liter. Okay, 1 liter. They are asking you, this 1 liter has a pH of 1. So initial pH is 1. Now they want to convert this into a solution of pH 2. They are asking you, how much water should be poured inside? How much liters of water should be poured inside to make it pH 2? Okay, so let's see now. Now when I say pH 1, it means the initial H plus concentration will be, if the pH is 1, then it is 10 raised to minus 1. The pH will be 10 raised to minus 1. Now I want to convert into pH 2, that means H plus concentration is 10 raised to minus 2. And we don't know, after adding this water, what is the final volume I want? Final volume. So, okay. We take this equation, M1 V1 is equal to M2 V2, where M1 and V1 are the initial concentration and volume. So initial concentration is 10 raised to minus 1 and initial volume is 1 liter. The final concentration is 10 raised to minus 2. What should be the final volume? V2. Now, final volume V2 will be 10 raised to minus 1 divided by 10 raised to minus 2. So, final volume comes out as 10 liters. 10 liters is the final volume. Now, final volume is 10 liters, remember. So, students, directly they try to write the answer 10 liters, but that's not the correct answer. That means after adding water, the volume has become 10 liters. But they are not asking you what is the final volume. They are asking you how much water you have added. Now already there was 1 liter. Final volume is 10 liters. So how much is the water added? Will be the difference. Difference in both. So the amount diluted, they are asking you how many liters of water must be added. So added water will be final volume minus initial, that is 10 minus 1. So actually your answer is 9 liters. So your final answer is 9 liters, that is D. Okay. So we now move for the next question. Okay students, let us see a very interesting question. It says the pH of 10 raised to minus 10 NaOH solution is nearest to. Now, many times what will happen is, the concentration of NaOH is given as 10 raised to minus 10. So, OH minus concentration is 10 raised to minus 10. So many times what will happen is, students takes OH as 10 raised to minus 10, so POH will be 10, and then they directly say the pH is 4, because they know that pH plus POH is equal to 14. So many times what happen is, directly they take the POH as 10 and they say that pH is 4, but just mind it, how can you say that? It's NaOH, it's a base, cannot have pH less than 7. So you have to think properly. So in that case what you have to do, first thing, this is NaOH solution. So what they have given is, the OH coming out from NaOH is 10 raised to minus 10. Similarly, since it is a solution, from water also OH will come out. The OH coming out from water is 10 raised to minus 7. So what is the total OH? The total OH will be now OH from NaOH and OH coming from water, H2O. So this is given to you as 10 raised to minus 10 and this is 10 raised to minus 7. So we take out common from here, 10 raised to minus 7. So this will become 10 raised to minus 3 plus 1. So this will be 1.0001 001 into 10 raised to minus 7. can be written as 1001 into 10 raised to minus 10. Now you take out the POH. POH is negative log to the base 10 of OH minus. So this will be minus log to the base 10 of 1001 into 10 raised to minus 10. So it will be 10 minus log of this 1001. It will be 3.004. 3.004. So when you subtract it, 6.996. This is POH, but we wanted pH. So pH will be 14 minus POH. So 14 minus 6.996 is equal to 7.004. So approximately 7. So your answer for this question is D, that is 7. So let's go for the next question now. The KSP of silver chromate is 1.1 into 10 raised to minus 12 at 298 Kelvin. The solubility in moles per liter of silver chromate in 0.1 molar silver nitrate solution is. Okay. Now silver chromate Ag2CrO4 dissociate to give you 2 silver ion plus CrO4 1 minus. Now the KSP of it is given as 1.1 into 10 raised to minus 12. So KSP is Ag square into concentration of CrO4 minus 1. Now let the solubility of Ag2CrO4 Bx. Therefore in this case it will be 2x and the solubility of CrO4 minus will be x. Now in this we are adding silver nitrate, which is a very strong electrolyte. So AgNO3 dissociate to give you Ag plus and NO3 minus. So the concentration of this is 0.1 and this is 0.1 given to us. Now as you can see, silver ion is common and effect. Now total silver ion from here will be the sum of both. So 2x plus 0.1. But then due to common and effect, this is suppressed. The dissociation of silver chromate is suppressed. So the solubility which is coming out from here is very small. So the total Ag plus, we take it approximately 0.1 only, neglecting 2x from here. So for the solubility of Ag plus, I am writing 0.1 square, and what is this? Into x, the solubility of chromate ion, CrO4 minus 1, and KSP is given as 1.1 into 10 raised to minus 12. Now after solving this, x will be 1.1 into 10 raised to minus 12 divided by 0.1 into 0.1. So this will be 1.1 into 10 raised to minus 12 and this 10 raised to minus 1, 10 raised to minus 1 makes up 10 raised to minus 2, which will go on the top. It will become plus 2. So your final answer will be 1.1 into 10 raised to minus 10 is the answer for this question. So your option B is correct for this question. Okay. Chalo, let's go for the next now. We'll go for the next question. So the final answer for solubility is moles per liter is this much. So we go for the next question now. Which of the following salt does not get hydrolyzed in water? What is the meaning of the word hydrolysis? Which salt undergoes hydrolysis? There are three types of salts which undergoes hydrolysis. One, salt of weak acid, strong base, weak base and strong acid, or weak acid, weak base. These are the three types of salts which undergoes hydrolysis, is hydrolyzed in water, whereas salt of strong acid and a strong base undergoes neutralization. It undergoes neutralization and not hydrolysis. So these are the salts which undergo hydrolysis in water. Hydrolyzed. Now let's take option one by one. The first option is potassium perchlorate. It's a salt of a strong base KOH and a strong acid HClO4 perchloric acid. So this is strong base and this is strong acid. So this is a salt of a strong acid and a strong base. So option A is a salt of a strong acid and a strong base. Whereas if I take B option, it is ammonium chloride, which is made from ammonium hydroxide and HCl. This is a weak base and HCl is a strong acid. So it's a salt of weak base and strong acid. So ammonium chloride is a salt of weak base and strong acid. What about option C? Option C is sodium acetate. Sodium acetate made from acetic acid and sodium hydroxide. So it's a weak acid and a strong base. So it is made up of weak acid and a strong base, a salt of weak acid and a strong base. So looking at this option, what conclusion you come to? Which salt does not get hydrolyzed? It is KClO4 because it's a salt of a strong acid and a strong base. So your answer is A for question number 9. Let's see this question now. 0.1 mole of CH3NH2 methylamine, which is a base. Dissociation constant for weak base is given as 5 into 10 raised to minus 4 is mixed with 0.08 moles of HCl and diluted to 1 liter. That means the volume is 1 liter. What will be the H plus concentration in the solution? Now, how will you solve this question? Very interesting question. So first thing, methylamine is a base. Now when you are going to put it in HCl, it will react with HCl, giving you salt. that is CH3, NH3 plus and Cl minus. So you get a salt. Now initial mole for methylamine is given as 0.1 and HCl is 0.08. Initial mole was 0 for the salt when the reaction started, but once the reaction is over, final mole left out for methylamine will be, since they are in the ratio of 1:1, the mole of methylamine consumed will be 0.08. So left out will be 0.1 minus 0.08. This will be totally used up and this will be formed, 0.08 moles will be formed of the salt. This is salt. So the left out mole for the base will be 0.02. 0.02 moles is left out and formed is 0.08. Now we wanted H plus. Now this is a basic buffer. This is basic buffer. Basic buffer. Weak base and it's solved with a strong acid is a basic buffer. For basic buffer, we have POH is equal to pKb plus log to the base 10 ratio of salt concentration upon base concentration. Now putting the values here, what is pKb? Negative log of Kb. So negative log to the base 10 of Kb is your pKb plus log to the base 10. What is salt? The concentration of CH3, NH3 plus Cl minus upon the base, that is methylamine, concentration of methylamine. So now negative log to the base 10 of 5 into 10 raised to minus 4 plus log of, this is 0.08 divided by 0.02. So this will be 4 minus log of 5, which is 0.6990 plus this will be log of 4. Log of 4 is 0.602. So when you add them, it is 3.903. 3.903. So now this was POH, but we are interested in H plus. So now we require pH for getting H, that is 14 minus POH, that is 14 minus 3.903, which is nothing else but 10.097. 10.097 is the pH, but we are not interested in pH. We wanted H plus. Now therefore we know that pH is nothing else but negative log to the base 10 of H plus. So if I want H plus, it will be anti-log of pH value. So anti-log of 10.097, which is anti-log of 10.097 is 8 into 10 raised to minus 11 approximately. Okay, so your H plus value will be 8 into 10 raised to minus 11. So your answer for this question is B, which is the correct option. Okay, so with that we end the chapter equilibrium. I hope so you enjoyed it. Now we'll be meeting again with a new topic. Till then, remain happy, remain safe and work hard. See you all.